Hi students, today we will discuss a problem on sequence and series which is given in JEE Advanced Exam 2010. Now coming to the question, let Sk, where k is from 1 to 100, denotes the sum of the infinite geometric series whose first term is k minus 1 by k factorial. So in this infinite geometric series, a equals to what? K minus 1 by k factorial, right? And the common ratio is r equals to 1 by k, right? Then we need to find the value of 100 square by 100 factorial plus sigma k equal to 1 to 100 modulus of k square minus 3k plus 1 times of sk is. Now they has given the values of k is ranging from 1, 2, 3 and so on up to 100, right? Now what is sk actually? It is the sum of the infinite geometric series, right? Now in case of k equal to 1, for suppose, what is a is 1 minus 1 by 1 factorial, which is nothing but 0. In case of a equal to 0, s1 does not exist, because of if the first term becomes 0, some of the infinite geometric series we can't create, so that s1 is 0 in case of k equal to 1. So we can't create the sum of the geometric series, so s1 we can say that it is 0, right? We can't consider s1. Okay, then here I just want to find sk, that is what? A by 1 minus r, because of that is the sum of infinite series. What is a? That is k minus 1 by k factorial whole divided by 1 minus 1 by k. So sk is equals to k minus 1 by k factorial whole divided by k minus 1 by k. So that k minus 1 gets cancelled. So clearly it is what? K by k factorial. So sk equals to k by, this is what? K into k minus 1 factorial. So that k gets cancelled. So clearly sk equals to 1 by k minus 1 factorial, right? And do remember that here k value clearly starts from 2 and ends with 100. We can't consider k equal to 1. That is what very important point here. Then now coming to the question, it is from 100 square by 100 factorial. Now let's discuss about this later. And now move on to the value, which is nothing but sigma k equals to, here actually given that k equal to 1 to 100, but in here sk is also there in the summation. So I'm just converting that k equal to 1 to 100 to k equal to 2 to 100 modulus of k square minus 3k plus 1 into 1 by k minus 1 factorial, right? Then sigma k equal to 2 to 100 modulus of that k square minus 3k plus 1. In order to find the sum of terms like from 100 times 100 terms, infinite terms, we can't find the summation that much easily. To find that sum, we want the pattern to simplify the summation, means which we need to cancel out some values. Unless otherwise we can cancel, it is very difficult to find the summation of that much huge quantities. So to get the sum very simple, we just want the term to be cancelled out. So in order to cancel, I want to create a difference between the terms, which is like here k square minus 3k minus 1, I can write it as k minus 1 whole square minus k, right? Because of k minus 1 whole square is nothing but k square minus 2k plus 1, and the rest of the term k divided by k k minus 1 factorial, and then sigma k equal to 2 to 100 modulus of, if you separate, k minus 1 whole square by k minus 1 factorial minus k by k minus 1 factorial. Right here, sigma k equal to 2 to 100 modulus of, this is what, k minus 1 by k minus 2 factorial, because of this k minus 1 factorial we can write it as k minus 1 into k minus 2 factorial minus k by k minus 1 factorial. Now start substituting k equal to 2, so that the first term will become modulus of, if you substitute k equal to 2, it will be 1 by 0 factorial minus 2 by 1 factorial plus modulus of then so if you substitute 3, 2 by 1 factorial minus 3 by 2 factorial plus if you substitute 4, 3 by 2 factorial minus 4 by 3 factorial plus if you substitute 5, 4 by 3 factorial minus 5 by 4 factorial plus and so on, plus now coming to the 100, modulus of 99 by 98 factorial minus 100 by 99 factorial, right? Then here, if you see the first modulus, 1 by 0 factorial is nothing but 1 minus 2. It's a negative quantity. In case of that modulus, I can separate this one as, so 1 minus 2, as I like, can write it as 2 minus 1 also, no problem, right? Plus modulus of this one, 2 minus 3 by 2, it's a complete positive quantity. I just want to keep as it is. So in case of it is a positive quantity, no need to write the modulus. So here what I am trying to do is, here the first term I can say that it is 1 itself, right? Because of that is 1 minus 2, that is 1 only. Next term I can say that 2 by 1 factorial minus 3 by 2 factorial. I just want to eliminate the modulus from this because of it is already a positive quantity. Next, from this also 3 by 2 factorial minus 4 by 3 factorial plus 4 by 3 factorial minus 5 by 4 factorial plus and so on, plus 99 by 98 factorial minus 100 by 99 factorial. Now here these two things, terms which we can cancel, so that 1 plus 2, it is 3, these two will get cancelled, minus plus, observe the pattern, minus plus minus plus minus plus. So the last value which will remains is minus 100 by 99 factorial. Now coming to the question, which is 100 square by 100 factorial, it is, we have to add with the 100 square by 100 factorial plus the remaining part is nothing but 3 minus 100 by 99. If you multiply with 100, that is what, 100 square by 100 into 99 factorial. So that is what, 100 square by 100 factorial plus 3 minus 100 square by 100 factorial. These two will get cancelled. Now the final answer is 3.